Hello everybody, welcome to this vlog. My name is Satya. In the last few classes, especially last two vlogs, I discussed about uh, the routing protocols introduction, in which I discussed about OSPF, BGP, ISIS. These are the three main routing protocols implemented in enterprise access, ISP, internal ISP network, and in the internet, right? So that corresponds to OSPF in enterprise access side. Internal ISP is ISIS protocol for exchanging the routes, and BGP in the internet between core routers. Then I discussed about why OSPF does not scale well in my second video. So to recap, OSPF does not scale well because of its link state advertisements or link state paths that have been used to exchange the routing entries is huge and very elaborate. It takes a lot of CPU processing power, right? So it is more CPU intensive, and for loading the routers or rebooting the routers, right, from bootstrap, if there is an IP failure, then OSPF also OSPF routing entry exchange also fails because it is IP dependent, internet protocol dependent. So now, this video will focus mainly on how intermediate system scores over OSPF in getting itself implemented in ISP networks. First point, ISIS is based, the routing entry exchange takes place at the layer 2 level. So I have described in one of the videos what is the difference between TCP/IP and OSI model, right, in my initial videos. Please, I'll put a link to that video in the description box. You can go through that particular vlog to understand what is the difference between TCP/IP and OSI model. So ISIS does not use internet protocol for routing entry exchange. It uses this technology called as CLNS, which is based on NSAP addresses. It is layer 2. It does not use IP addresses at all for routing entry exchange. So it has a better bootstrapping. That means when the router comes up, it does not depend upon the IP layer to be active, right? So first the routing entries get populated in LSDB, right, in the routing database, and then you can fix the IP routes easily, the administrator. So to recap again, ISIS works on layer 2 domain and uses mainly CLNS and NSAP addressing format. It does not use IP, so IP failure will not block ISIS, whereas OSPF is based on IP, and IP failure means OSPF failure, right? That is why ISPs prefer ISIS over OSPF. Then the second point, flat core architecture. Flat core means in the ISP network, the core routers has to form adjacency, right? So in case of OSPF, it is area based distribute. For example, one area is shown as area 0 and area 1 ASPR router, and then autonomous systems. Between autonomous system, BGP is used. So area 0 ASPR router will act as a bridge between two autonomous systems, like that, right? So it is area specific OSPF. It is hierarchical router distribution, that is area 0, area 1, area 2, area 3, like that. But ISIS is flat core architecture. Every router in the core network will have the same LSTP, that is router database. All the routing entries are equally distributed across all the routers. It's not the case in case of OSPF, in a simpler words. So that's the reason why ISIS is preferred in ISP architecture, because of its flat core. ISPs measure the downtime for years. So ISIS promises stability and very less downtime because it is layer 2 specific and it has flat core architecture. Each core router in the core network has LSTP, which is similar to all the other routers in the core network. So that is the reason why ISIS scores over OSPF. It's not because OSPF is weak, it's because of the advantages of ISIS that scores over OSPF. Then ISIS has native support for IPv4 plus IPv6. OSPF has OSPF version 2 for IPv4, OSPF version 3 for IPv6. So the migration takes a lot of money and human resource for OSPF implementation in core routers. But in case of ISIS, that's not the case. It is natively supported for both IPv4 and IPv6. Long-term stability, as I told, since it uses layer 2 for exchanging the routing entries, and the convergence takes lesser time, and it is IP independent since it is layer 2 that is used for exchanging the routes, and because of the flat core architecture of ISIS has a longer stability. MPLS and traffic engineering, right? So ISIS supports tremendously, exceptionally well the MPLS and traffic engineering concepts. OSPF also supports, but what I'm trying to tell here is ISIS has more advantages than OSPF. Learning curve. OSPF is very easy to understand, but ISIS is TLV based, so it takes some time for the administrator to understand the protocol, right? So learning curve is steep in ISIS. This is the only area where OSPF scores above ISIS. That means its routing protocol is very easy to understand. So to summarize, friends, ISIS scores over OSPF because of its own advantages rather than the weakness of OSPF. To summarize, ISIS has layer 2, OSPF has IP, Internet Protocol, for routing entry exchange. OSPF uses hierarchical architecture for core router concept, but ISIS uses flat core architecture. ISIS has longer stability, that is the most important point for ISPs. ISIS has native support for IPv4 plus IPv6, whereas OSPF supports in two versions, OSPF version 2 for IPv4, OSPF version 3 for IPv6. So friends, this is the reason why ISIS is preferred. So in the next classes, we'll discuss each protocol in depth and understand. Now we understand why ISIS is used, why OSPF is used, and why BGP is used in the core, in the internet. So now the next concept is to understand each protocol and dwell more in-depth knowledge about these protocols. Thank you. See you in the next video. Bye.